Welcome to this explainer. Have you ever wondered why some of your favorite apps are constantly improving while others are just, well, a buggy, broken mess? It literally all comes down to the foundation. We're talking about the evolution of the SDLC lifecycle model. We're going to dive into how the software engineering industry finally shifted away from those rigid, highly risky early models and moved toward the dynamic, automated, and secure systems that are running today's tech world. To do this, we're going to track this whole evolution chronologically. We'll hit the traditional waterfall approach, look at the agile and iterative shift, see how we started automating with case tools, and finally wrap up by securing the system lifecycle.
All right, let's jump right into section 1, the traditional waterfall approach. This is really where software engineering first found its footing.
Think of this traditional SDLC lifecycle model as a strictly sequential journey. You got your steps, requirements, design, development, testing, and finally maintenance. You do one step at a time, and there is absolutely no skipping ahead. The metaphor here is incredibly literal. It's like a waterfall. You complete one phase entirely, let's say design, and then you flow downward right into development. And once you drop down, it's basically a trapdoor. There's almost zero intention of ever flowing backward to revisit a previous phase once it's officially marked as complete. And because you can't go backward, well, you better get it right the first time. This lengthy, upfront planning approach ends up being incredibly risky, highly costly, and honestly, downright dangerous if your project goals suddenly change. I mean, just imagine finding a fatal flaw in the testing phase. At that point, it's a massive, incredibly expensive setback. No way around it. So, that inherent risk paved the way for a much-needed industry revolution. Let's move into section 2. The agile and iterative shift. Instead of spending months trying to predict the future with a sequential waterfall, Agile Scrum brings in a just-in-time approach. We're talking about moving from lengthy upfront requirements and strict phases to a prioritized, highly dynamic product backlog. Features are progressively refined as the team actually works, adapts, and learns more about the project in real time. It's a total game changer. This paradigm shift totally replaces those massive, isolated developmental phases with practices like test-driven development, or TDD. Under TDD, a programmer works in very, very short cycles. You literally identify a failing test, write just enough code to pass it, and then clean it up. So the team learns by doing a little bit of everything, analyzing, coding, testing, all at the exact same time, repeating the cycle in minutes instead of hours. But change is never completely seamless, right? Throwing dynamic agile practices into a traditional sequential organization causes a whole lot of friction. Researchers Boehm and Turner actually identified 3 major clash points here. First, the development process differences themselves. Second, how developers interact with business leaders who are still expecting those rigid traditional updates. And third, the people. Suddenly, individuals have to adapt to cross-functional, self-organizing teamwork, which can be a huge cultural shock. Okay, so once we organized our teams to be agile, the next evolution was all about speed. That brings us to section 3, automating with case tools. Computer-aided software engineering, or case tools, actually have a surprisingly long history. The concept first emerged way back in the 1960s. The term itself was officially coined in 1982, hit peak popularity as a booming market in the early 90s, and eventually evolved into the modern integrated solutions we rely on in the 2000s and today. These automated frameworks generally fall into a couple of different types, based on what part of the SDLC lifecycle model they support. You've got uppercase tools, which focus strictly on early planning, analysis, and design. And then you have integrated case tools that seamlessly span the entire lifecycle. We're talking about tools you probably use every single day for sure. Visual Studio for coding, Jira for managing that dynamic backlog, and Selenium for automated testing. But hey, speed and agility mean absolutely nothing if the product isn't actually safe. So let's dive into section 4, securing the system lifecycle. This is the ultimate armor of modern development. Enter the SDLC. That stands for Security System Development Lifecycle. This is a comprehensive framework designed specifically to weave robust security measures directly into the very fabric of system development, rather than just, slapping them on as an afterthought. Rather than bolting on a padlock right before release, SDLC is all about a continuous process. It manages security from initial planning all the way to system retirement.
It integrates security into every single development phase for early mitigation, meaning it proactively identifies and addresses flaws early on. It's a totally holistic approach covering all aspects of system security to protect data and ensure compliance right from day one.
Look at how this maps out. It perfectly mirrors those original sequential steps we discussed at the very beginning, but it completely supercharges them. It injects rigorous risk assessments directly into planning. It puts detailed threat models right into the analysis phase. It builds security architecture into the design and demands secure coding right at the implementation phase before moving into maintenance. It's brilliant. Now, how do organizations actually know if these highly complex, secure, and agile processes are working? Well, they measure them. They use objective maturity and process improvement standards, things like SCAMPI, which is a 5-step process assessment, or CBA-IPI as a diagnostic technique for maturity. There's also SPICE for objective evaluation and ISO 9000-2000 for quality improvement. At the end of the day, it's all about continuous, measurable improvement to make sure the software is actually getting better over time. So, as we wrap up this explainer, let's just look at the big picture. The SDLC lifecycle model has been completely transformed. It's fully iterative through Agile, it's highly automated by robust case tools, and it's heavily armored by the SDLC. So as things like AI and machine learning step onto the scene, what will the next era of software development actually look like? Will the software of tomorrow just end up writing itself? Definitely something to think about. Thanks for learning with me today.